All right, so we're going to talk about 4A.1 classifying triangles. So our first topic is classifying triangles by, this is actually supposed to be angles, so if y'all want to go ahead and change that. Okay, so for classifying triangles by angles, if we have an obtuse angle, it's going to be an obtuse triangle. If we have all three angles that are acute, it's going to be acute triangle. If you have one right angle, it's going to be a right triangle. Okay, and then if all three angles are congruent, it's going to be called equiangular. Okay, so let's look at some examples. So based on our picture, we're going to classify all of these triangles. So if we look at CDE, you can go ahead and highlight that real quick. CDE is this one right here, and that does have a right angle, so that's going to be a right triangle. Okay, so then we have BCE, so B to C to E, that's this one right here. Okay, and at angle C, it's an obtuse angle, so that's going to be an obtuse triangle. All right, then we have A, B, E, A to B to E. All right, and those markings tell us that all those angles are congruent, so that's going to be an equiangular triangle. All right, then we have BDE, so B to D to E. Again, at angle E, we do have that obtuse angle, so that's going to be an obtuse triangle. And then CFE, okay, all of those are less than 90, so it's going to be acute triangle. Okay, these are the ones that we're going to classify by sides, so if you want to change that to sides. Okay, if it has all three sides congruent, y'all do have heard of this one before, it's equilateral. All right, then if it has two congruent sides, that is going to be isosceles. And then if it has no sides congruent, that's going to be called scalene. Okay, so if we have our picture here, we just want to identify, so JKM. Okay, none of those sides are the same, so it's going to be scalene. Sorry, y'all, this should be JKM. Okay, then we have KLN. All right, that should be isosceles. All right, and then our last one is going to be JKN. And that will be your equilateral. Okay, so on this side, it wants us to classify it by angles. Go ahead and change those three. It did just have the wrong set of triangles. Okay, but if we look at our triangle here, I'm going to go ahead and figure out what the missing angles are. So this one is going to be 80 because they're next to each other, so they have to make a straight line, which is 180 degrees. All right, then this angle up here. Okay, I know that triangles have to add up to be 180, so this one is going to be 30 degrees. And since that is a right angle up there, I know that this side has to be 60 degrees. So that's going to kind of help us through the rest of it. So if we look at ABD, okay, it does have a angle greater than 90, so that's going to be obtuse. And then ADC, it does have that right angle at the top, so that's going to be our right. Okay, then we have BCD. All of those are less than 180, less than obtuse, so it's going to be a acute. All right, so let's go ahead and look at classifying by sides. So again, just the angle measure was left off, so these all should be 8. Okay, so if we look at the whole triangle, GIJ, if we add this side together, it's going to be 16. Okay, and then the other two sides are 8 and 6.9, so none of those are the same, so that's going to be scalene. All right, then we have HIJ, where all of those are the same, so it's going to be equilateral. And then we have GHJ, where just two of them are the same, so that's going to be isosceles. Okay, so then our last topic for this one is going to be using our distance formula to classify triangles by sides. Okay, so if we recall, our distance formula is used to find the lengths between 2 points. Okay, and that formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so it says draw the triangle and label each vertex, find the lengths of each side, and then classify the triangle by its side. Okay, so let's say we have a triangle. Okay, I have no idea what it looks like. Okay, but I know that this side is J, this side is K, and this side is L. J is at -7, -7. K is at -9, 1, and then L is at -1, -1. All right, so what we have to do is find the length of each side. So we're going to start with JK, and we're going to use the distance formula for each of those. Okay, so I'm going to do the square root, and it doesn't matter which one's x1, y1, x2, y2. So I'm going to do -9 minus -7 squared plus 1 minus -7 squared. Okay, and both those negatives turn to positives. Okay, so -9 plus 7 is -2, and then -2 squared is going to be +4. All right, and then 1 plus 7 is 8. 8 squared is going to be 64. So this comes out to be square root of 68. Okay, so then let's do KL next. All right, so I'm going to do -9 minus -1 squared plus 1 minus -1 squared. And again, both those negatives turn positive. Okay, so then I have -9 plus 1 is -8, and then -8 squared is going to be 64. Okay, and then we have 1 plus 1 is 2. 2 squared is going to be 4. And again, this one's also square root of 68. So right now, I know that JK and KL are all the same. So now I need to figure out the last side, JL. And if it's the same, it's going to be equilateral. If it's different, it's going to be isosceles. All right, so let's do -7 minus -1 squared plus -7 minus -1 squared. Okay, again, switch those double negatives. So I get -6 squared, which is 36. Same thing on this side. So I get square root of 72. So since that one's different, it's going to be an isosceles triangle. Okay, so our last problem, number 16, is going to work the same way. Go ahead and do that one, and then once you do that one, come back and we'll have your answer. Okay, so this one should also be isosceles. Okay, your side measures should be square root of 260, square root of 130, and then square root of 130. All right. Okay, so let's look at using algebra to find missing sides of a triangle. So if we look at number 17, okay, so let's find the sides of or if it's an equilateral triangle, find x. Okay, so here are our values. Well, if they're all equal, all we have to do is pick just two sides. Okay, set them equal to each other. So if I do SR and ST, for example, I could do 12x minus 22 equals 10x minus 6. Okay, I subtract 10x, I get 2x. I do add 22, so negative 6 plus 22 is positive 16. Divide by 2, so x is going to be 8. Okay, so that's only part of the question. I do need to plug that back in. Okay, so let's say I plug it in for ST. I get 10 times 8 minus 6. So that's 48 minus 6, which is going to be, 80 minus 6, which is 74. And since it is equilateral, I know that every single side is going to equal 74. So SR, ST, and then RT are all equal to 74. All right, so number 18, I do want y'all to do on your own. So go ahead and pause here, complete it. Okay, so after finishing it, you should have gotten x equals 13. And again, since this is isosceles, you just plug it in. So we know NP is x plus 14, which is just 13 plus 14. So it's 27. So all of your sides should equal 27. Okay, so if DEF is an isosceles with an isosceles triangle with EF congruent to DE, okay, find x in the measure of each side. So we know EF is congruent to DE. So those would be the two sides that you set equal to each other. All right, so we subtract and then we add 13. So we're going to get x is equal to 10. And then it does say find measures of each side. Two of them are going to be the same. So we know that EF is 5 times 10 plus 17. So that's going to be 67. So then we would know that DE is also 67. And really the only thing left that you would have to do is plug it in for DF. So 10 plus 21 is 31. Okay, so go ahead and give number 20 a shot. All right, so again, we have another isosceles triangle. XY is congruent to WX. So those are going to be equal to each other. And then you should get x is equal to 27. And then plugging it in, your sides are going to be WX equals 85. XY equals 85, and then WY equals 104. Okay, and then this last one, we have an equilateral triangle. Okay, so here's your equilateral triangle. All right, we have triangle STU is an equilateral triangle. ST is 1 less than twice x. So 1 less than twice x is 2x minus 1. SU is 37 less than 5 times x. So that's 5x, and then 37 less than that. And then TU is 11 more than x. Okay, and again, since it's equilateral, just pick two of the sides, set them equal. So if I have 2x minus 1 equals x plus 11, you're going to get x is equal to 12. All right, and then to find the measure of each side, just plug it in. So UT is going to be 12 plus 11, which is 33. All right, so that means all the sides are, 23. So all the sides are going to be the same, which is 23. All right, and that is it for 4A.1.